I'm Caleb Harris. Thanks for joining me. Today I want to show you how to join boards on a curve as opposed to a straight line. First, I'm talking about why we're going to do it, then why doing it is so convoluted, and then we'll jump into the action. So I like to answer questions by asking the opposite question. So why do it? Well, why not? Well, we normally do things in straight lines and join panels with straight edges because they're just easier to make. All of our tools and machines, well, most of them are set up to cut straight, square, flat lines. And naturally, once you have that straight, square, and flat edge, they join together really naturally. But as you know, the grain in boards is normally not straight. It almost always has curves. And especially when you're doing a panel, you're dealing with the face grain, which has those cathedral shapes in it. And once you rip a straight line right through that, your eye is drawn to it. So when you look at a tabletop, it's normally really easy to tell each individual board because those natural curves are broken up by straight lines that our eyes are drawn to. Well, I'm making a tabletop out of two large sycamore slabs that were sequenced on, meaning they were right beside each other in the tree, so the grain is very similar in both of them. So instead of interrupting all that naturally curving grain with a straight line that's going to draw your eye, I want to create a curved edge profile that matches each other so we can get a good strong glue joint, but that your eye isn't naturally drawn to. So when you look at this tabletop, it looks like one large slab. I'm going to use these pieces of cardboard to illustrate the issue in trying to get two matching curves without a large form CNC to do it for you. So I cut these with a scissor, and as you can see, they match well. The problem is in woodworking, the tool we have to make curves like this is either a bandsaw, which most slabs are just going to be too big for most bandsaws, and you're going to have a rough cut, which means you have to smooth it afterwards anyways, and then they're not going to match. So we're probably going to choose to use a router, but a router bit, we're going to pretend this bottle is my router bit, has a width, and that's going to change the radius of each curve. Let me try to explain. So what we would do with a router normally is you'd get one edge good and then use some type of bit with a bearing surface to ride and transfer the edge. But the issue lies in the diameter of your router bit. So let me line these up, and let's say that this is my good slab and I'm trying to copy my edge, and I'm using my router with some type of a template bit, and this is what I get. Now right now they look pretty good, but let me put them beside each other, and what you'll notice is that once we line up sort of the peaks and valleys, there's these gaps on the curves because the width of the router bit changes the radius of these circles. Just know that the width of your router bit is going to cause an issue and make these not match. Now obviously this is a lot larger than most router bits, so the problem is going to be less noticeable with the smaller router bit, but it still creates enough of a difference that you don't have a strong glue joint and it might be noticeable. Okay, let's say these represent our two slabs and the blue cardboard is my template. Now, when I run my bit, and I know this has a bearing in it, when I run my bit here, I'm actually going to be cutting on what we call the near side of the bit because this part is my waist and this is my keep. But when I move to the other side and try to cut my template with my bit, then what I'm cutting is actually going to be with the far side of the bit because this is my keep. So instead of using a bearing, if we use a bushing, because we're going to cut on both sides of the bit, we can use bushing sizes to eliminate the diameter of the bit as a problem. So the bushing is basically a shroud on the base of the router, and then the bit is inside of it. The edge of the bushing is what's going to ride on this template. When we make our cuts on one slab, we'll cut on the near side of the bit. On the other slab, we're going to cut on the far side of the bit. So by changing this bushing, we can actually cut the same distance away from the edge of the template both times. Here's what that looks like. So when we cut the first slab on the near side, let's say we want the bit right here, so we can cut on the near side. So our bushing will be sized to get us a distance away. And then when we cut on the other slab, that's going to stay over here, we're going to be cutting on the far side of the bit. So here's our bit, and we'll just use a smaller bushing. So that way both cuts are the same distance from the edge of the template. Because they're both the same distance from the edge of the template, the radius of these curves will be the same. Now I'll spare you all the math, but this works out pretty well with if you use a 1/4 inch bit, and then for the big bushing you use a 3/4 inch bushing and the small one as a 3/8 inch bushing, then this cut line is going to be really close. It's not going to be perfect, but the difference between where these two bits cut inside a 3/4 inch and a 3/8 inch bushing is only going to be a 1/16 of an inch. Whereas if you just used a 1/4 inch patterning bit, then you're going to be a 1/4 of an inch off. So while it's not perfect, this difference of 1/16 eliminates 75% of the error you're going to see using a 1/4 inch bit. You can ignore those blue chalk lines. That's just where we would have straight line ripped the slabs. But as you should have gathered by now, there's nothing straight about this project. The first step is establishing the curve that will become the edge of the slab. The idea is to follow the grain, but keep the curves fair and sweeping. Tight curves or too much zigzag will draw attention. Now that the line is established, Matthew made the first router pass freehand. After the first pass was done, I cut off most of the excess with the jigsaw. If we had roughed in with the jigsaw first, there would have been less support for the router. With most of the waste gone, a few passes with a patterning bit quickly flattened the edge. However, the curve is pretty rough and has a lot of ripples in it right now because it's based on that first freehand pass. To smooth things out, I used a sander to establish a bevel on one of the edges. The 6-inch pad is wide enough that it doesn't follow all those little imperfections, but creates nice fair curves. Now the trick is making the rest of the edge as fair as that sanded edge. To do that, I set the patterning bit so the bearing will just barely kiss the top of the slab and follow that sanded line. Then it's just a few passes and the edge is looking much better. There was a little flap left from the gap between the bearing and the cutting edges on the bit, but some light sanding cleaned that up in no time. Before making the template, I went ahead and transferred the line to the other slab and roughed it out with a jigsaw just because I wanted a peek at what things would look like when finished. Just like the slabs, the first thing I do to make the template is rough it out with a jigsaw to minimize how much cutting the router will have to do. Then I lined up the template with the clean edge I made earlier and used a pattern bit to copy that profile to the template. With the template done, the rest of the process goes pretty quick. We extend the template over the edge of the slab a bit to give the router some clearance and clamp down the far slab just close enough to remove material down the entire length. The bit is only set deep enough to give enough surface for the bearing of the large template bit to ride on. This slab is cut with a 1/4 inch bit and a 3/8 inch bushing, so the bit is actually cutting 5/16 of an inch from the edge of the template. Now it's time to recut the first slab with the template. This cut is made with a 1/4 inch bit and a 3/4 inch bushing, so we're actually cutting a 1/4 inch away from the edge of the template. So there's only a 1/16 of an inch difference from the other slab, which is how we're able to get the curves to match so well. The only thing left is to put in a flush trim bit and flush up the rest of the slab's edge. Now the slabs are ready to be joined. I cut in some dominoes because there was one available at the shop where I was working, but you could also use biscuits or dowels to help alignment. This video is just one part of a table build. I'll put a card and a link in the description to the full build when that video is complete. In the meantime, make sure you like and subscribe so you don't miss it when it comes out. If you want to see more content from me, go check out my Instagram. There's a link in the description where I post daily. If you want to help support me to get more videos like this out, then consider becoming a patron at patreon.com/YouCanMakeThisToo or just hitting that share button. Thanks.